Hi everyone, welcome to my channel. This video is part of a playlist on AKS, Azure Kubernetes Service Networking. Today's topic is Docker networking and overlay networking using Docker Swarm Cluster. This is a foundational concept to Azure AKS CNIs. We will start with a single Docker host today, then we'll spin up a few containers, we'll spin up a few networks, run some validations from the command line. Then we will introduce the concept of multi-host networking, and then the core concept of overlay networking using Docker Swarm Cluster. Lots of action, let's get started. So what you see on my screen, let me get you familiar, is again, this is part of the AKS Networking Art of the Possible series. And today's topic is Docker networking and Swarm Cluster, basically overlay networking. Then we have a VNet in Azure already created, a subnet already created, and we'll start with a single Docker host, and we will introduce another one. All right, so very, very simple network. I have a script I'll share with you in a few minutes that creates this setup. Okay, so all of this, again, this is a draw IO, so all the diagrams and everything I'm showing today, including the scripts, is available on my GitHub repo link below. So let's jump on to VS Code. So again, I'll show you three scripts. There are three scripts in question. The first one is build Docker host, which is I have already ran it. So I've created two Docker hosts. Then there is a script about Docker networking basic, and then the third script for Docker Swarm cluster. So we'll look into each one of them as we progress through the session. So let's start with the first one. I've already run the build docker host.sh script. Few things to note over here is that it spins up two VMs with these names in its own resource group. Be sure to put your own public key over here so you could SSH in. And other than that, there is a couple other things I want to show you. It does install these two packages, NetTools and Docker IO. So it's ready for you to start playing with the containers and looking at the networking. And at the end, it does echo your IP addresses. So there I have it at a point where it's created the resource group for me, and I can now SSH into the VM. If you want to look at it quickly in the portal, in the Azure portal, this is the Docker resource group with all of these resources, including the networks and the NSGs. And then for NSGs, I do have two ports that are open, 22 and 8080, just from the VM, just from my system that I'm connecting from. All right, so let's split this screen so that we can jump on. Well, first we'll start with one Docker host, but we'll split this screen so that we're connected to both the Docker host, although we're going to start with just the first host. So that's the first host. Oops. And let's get into the second host here. All right, so we are now connected. So left is Docker host 1, right is Docker host 2. For the first half, we'll be focusing on Docker host 1. So I'm just going to push this aside so we have a little bit more real estate here. All right, so let's look at what this host looks like. So if I just do the IP adder command, you could see that I have my ETH0 interface with the 10.1.1.4, and then you'll see this Docker ETH0 bridge automatically installed over here. Now what this bridge is, it's think of it like a virtual switch. In what we will do is when we spin up containers, it will automatically connect to this Docker 0 bridge, and it will get an IP from that bridge. So let's do a quick visual on in Draw.io, and then we will come back in here and we'll start running through the basic. We'll start spinning up containers. But let me show you first in Draw.io. But I did want to show you that I have two hosts, Docker host, ready to go. So jumping back here, what we will do is we just looked at this Docker host, and it had an ETH0 interface with a private IP. And of course, it can reach out using a public IP as well. It has a public IP as well. And what we saw was this little virtual switch, or if you will, or Docker 0 bridge. And then we will spin up a few containers. So when you create the two containers, there is this important concept of, let me zoom in a little bit, important concept of this vETH pair. Docker creates this vETH pair. So there is one vETH that's placed on the Docker bridge side, and then the ETH0 is placed on the container side. And we'll look at all of these IPs that are assigned to this container. But notice how there is this layer 3 IP address, which Docker 0 bridge has its own layer 3 IP address, which is the default gateway for these two blue VMs. All right, and container to container communication, let's look at this real quick. So when blue container talks to this blue one talks to blue two, that communication happens through the Docker 0 bridge. And let's look at the inbound and outbound flows. Let me zoom in just a little bit. So outbound and inbound flows, when this container reaches out, it goes out through the IP address of the Docker host. And when you come in, you can expose the service as it's shown over here. You can expose the service 8080, which goes to 80 on the container. So both inbound and outbound works through the Docker host ETH0 IP, which is again on the Azure subnet. Okay, so that's a very basic out of the box, the network that comes with the Docker host. So we could also create a custom red bridge or a custom virtual switch, and we can plumb two containers in there as well. And the traffic will flow between between the red containers. They should be able to talk to each other. However, this flow from blue to red will not work. Okay, so there are ways to make it work. You can dual home the containers, but out of the box, the blue will not be able to talk to the red bridge. So now let's introduce the concept. But let's first validate all of this in the command line. So we'll jump back in here and we'll go to this other script that I have. So again, it says make sure you are SSH'd in, so which we are. And first, we're just going to do it on a single Docker host. So as you saw, we do have the Docker installed by the script, but we'll still validate. Docker version is a very useful command. It gives you a lot of information. And we'll just do Docker info, another useful command that you can run to make sure that you have the right version installed. And let's do Docker PS. Now, Docker PS is to view running containers. So if you're in a brownfield environment and somebody had spun up a container, this is how you can validate that there's nothing on it. So this is greenfield. I didn't install anything. And images is also a very useful command. You'll see that these commands will show something after we run the containers. All right, so this is, and then container list is the same as Docker PS. So let's go ahead and we already did IP header, so run a container called hello world. Now, if you do Docker images, it shows you that it has the Docker hello world image here. And if you do ps-a, if you just do ps, let me first show you ps, Docker ps. Uh, it will not show anything, but if you do a ps-a, it will show you that this container ran and exited 9 seconds ago. And it gives these interesting names, unique names to the containers if you don't run it with a specific name. Now let's spin up our blue container. So going back into the visual, we're going to spin up these two containers and watch the networking inside it. So this will spin up a container called blue one. And we'll spin up blue two. Blue 2 was faster because it didn't have to download the image. So if we did Docker images again, you will see that it did install the Nginx demo image because this is nothing but the image that we specified. Okay, so that's what this Docker run command does. It spins up a container. Now let's do Docker PS again. And let's exec into blue one. Now that we specified name as blue one, we can exec into it with the name. And if we do IP adder over here, you will notice that it got an IP on the 172.17.0 network, which is the same as our Docker 0 network that we looked at here, 172.17.1. So clearly we have the right configuration there, and we should be able to ping at this point 8888, and we can run curl ifconfig.me, and it egresses using the public IP of the VM. And we'll validate that if you exit out of this and if you run the curl ifconfig.me from the host level, it should also give you this IP, and that is the unique instance level public IP on the Docker host. All right, so now how do we test inbound? The way you can test inbound is you can expose port 8080 on the host to 80 on the container. So let's do that. So there we have the port 8080 on the host is exposed to 80 on the container, and then we can validate that. Let's validate that. The best way to validate is let's grab the IP of this host, and then we will just open another window just so we don't lose this one. Maybe we just exit out of here. Or let me just open a new one here. So we will just do curl and then port 8080, and there we can just do it with just to kind of double check the configuration that we can connect, and we get a 200. Okay. All right, so now jumping back over here, we just tested inbound and outbound. We exposed the service on the host, which in turn maps to the container. So how do we now check? Let's check a couple other things. What we will next do is we'll spin up this red bridge and the two red containers. Okay. So for that we can do Docker network ls command first to see that nothing exists. So notice how we don't have any other bridge. These are just the default bridge. So we'll, in case you did have something, you can use this rm command, and we will we will use this command to specify the subnet for our red bridge. and we'll go ahead and create that one. And then let's run the ls command again, and we can now see the red bridge created over here. There is another command called docker network inspect, which we will look at after we spin up a couple of containers. So here we will run this command to spin up the red one container. We'll do the red two. And notice that we're being very specific about the IP that we want to assign to it. This is so that we can then, when we add the additional host, we have unique IPs. So if you didn't specify it, it will automatically assign you the first available IP in the 172.20 network. And that was the red bridge that we created. So now let's run a few commands to inspect the bridge. So first we'll run docker ps, and you can see that we have a few containers here. We'll just run. So we have two red containers, we have two blue containers, and what we will do is we'll inspect this bridge. Now, when you inspect this bridge, it gives you it's a very useful troubleshooting command. It gives you the subnet, and then it also gives you the individual IPs of the containers that are on that, attached to that bridge, right? So between Docker PS and Docker Network Inspect, you get a lot of information. So now let's exec into the red pod. If you do the red container, if you don't want to actually exec in, you can just run the ifconfig command, and it shows you that it got an IP in the red network, the 172.21 network. But let's SSH in and then run IP adder. We can also do ping 8.8.8.8. It can reach out. We can do curl ifconfig config.me. You get it egresses using the public IP of the host it is on. And interestingly, now that we are on red 1, we can ping red 2. Okay, so red 2 is working. So we have east-west connectivity. We can go out, we can come in. So everything is working very well on the single host. Now, let's introduce the concept of multiple hosts. So imagine now that we have a second host. So now that we have a second host, that Docker host will have its own, this Docker 0 bridge, the blue bridge, and then we'll spin up its own red bridge. And then we will see that it will also have its own ingress, egress. It should work independently. However, if you want to talk from this red container to this red container across the across host communication, it will not work. Now, how do we get that? And that's where we will introduce the concept of Docker Swarm Cluster. But first, let's go ahead and spin up these two containers in the second host, and we'll make sure that they can't talk to each other first. So we'll go here, and now we are on this second Docker host. If we do Docker network ls here, we do have the red bridge here. And if we do Docker network ls here, we don't have the red bridge on this one yet. And again, I'll just run an ifconfig here so that you will see that it is a base install of Docker. It is a base install of Docker, and it it has that default Docker bridge. So side by side, if you look at it, we do have a few more things now over here, but the ETH0, which is on the Azure subnet, is 10.1.1.4, and this one on this one it's 10.1.1.5, and you could see that the Docker 0 is identical. They don't each other, they don't know about this. They are independent of each other. So let's go ahead and create the red bridge over here. And so we'll go up here, we'll do Docker, we'll make sure our cursor is on this one. So when my cursor is here and I type there, it will echo over there. We'll do Docker network ls. And given we, on this host, we did 10 and 11. On this side, we will do, on the second host, we will do, oops, we'll do 12 and 13. Okay, so let's go ahead and connect that. And first time it will download the image, so it takes a few seconds, and then we'll do this. So if we do Docker, we'll do the exact same thing. We'll do Docker PS. And we will exec into the, in this time we will exec into red 3. So let's exec into red 3 because 3 and 4 are on this one. And if you do the IP adder over here, you could see that this one is 12. And let's exec in here in this red pod as well. And this red pod is 10. Okay, so from this red one, we can, if we do a host name here, it doesn't give the host name, but if we ping a red 2, red 1 is itself, red 2 works, but if we ping red 3 cross host, it doesn't work. This is because these two networks are separate. They're on separate hosts. They don't know about each other. So let's do another test here. We'll ping red 3 here, which is itself, and we'll ping red 4. Okay, so all of that is working nice. And we do have the each independent hosts working. So what we can do now is let me introduce the concept of overlay networking and the swarm cluster first. So we just noticed, and let me just fix this. This should have been, we forced it to get an IP of 10. So in our design, so this should have been just to, so there's no confusion from what you see here. And 10, 11, 12, and 13. I just forced it to be unique IPs, but even then we cannot reach from here to here because they're cross hosts. So, and then the other consideration I mentioned is you cannot even reach from one bridge to another bridge. Okay, you can dual home the container and then connect it, but by itself, you cannot. You cannot. So that's the consideration. So let's introduce the concept of Docker Swarm cluster. So with Docker Swarm, this two hosts will be part of a cluster. And then we will deploy the green bridge. We will deploy the green bridge, which spreads across both the hosts, and it's technically only one green bridge. And then we will verify that the green container on this host can talk to the green container on this the second host, and that is overlay networking. We will be extending the layer 2 broadcast domain across the host, and we will be doing VXLAN overlay. So we'll do layer 2 over layer 3. All right, and we'll do some packet captures to validate that that is indeed happening. All right, so this is the best part of the show here. So let's go back and let's go back onto our VS Code here. Let's do, I do have a delete command here, a cleanup commands here. So we will delete all of our containers that we ran. So there is a useful command called ps-aq, which shows you all of the um, containers that are running, and then you can, if you use the stop with it, it will first stop all of the containers and then remove, docker rm will remove the containers. And let's do the same thing on the other host, and we will do this. All right, so now we have a clean state. We can do docker network docker ps dash a. We don't have anything, and then we'll say docker ps dash a. We do have that. If we do docker network ls, we do have the switch that we created on the red bridge that we created, but we can leave it as is. No issue there. Now we are now ready to create the swarm cluster. So this was my second script, which just did single host networking. So now let's build the swarm cluster. So the way to do that is, let me clear my screen, and we'll clear the screen here. And we'll just make it even here so we can get a nice view. All right, so let's initialize the clusters, and we will make this as the master node. There is a concept of a master and a worker. And when we initialize it, it tells us that to add a worker node, run this command on the other node. So we'll grab this and we'll run this command over here. Now it says that it has joined the swarm as a worker. Now, what is a worker? We'll see that in a second. So if I now run the docker network ls command, we need to run it on the it says that you need to run that on the Swarm Manager. So when we run it here, it shows us that we have two hosts, host 1 and 2 in the cluster. And then we can run this service command just to make sure. Oops, I need to run everything um, on the main node. It just to validate there's nothing running. So now let's do a simple docker run command. We will run this demo 1 container and see what happens. In fact, before we do that, I want to show you, now that they're part of the swarm cluster, I want to show you this output. As you can see, there was this Docker 0 bridge that got created. Docker 0, Docker underbar gateway GW bridge that got created. And that was created after we paired them as a cluster. So that is used for routing traffic between, intended for the communication for the swarm cluster. Okay, so that's the new bridge network that got created. Okay, so keep that in mind. So now let's go ahead and run this container. So we'll run this on this one and we'll run it on this one. Now, if we exec in, we'll do it on both sides. You'll notice that they both have the same IP. So this this bridge that I showed you on the 172.17 network. So this bridge that I showed you here, Docker 0 bridge, is still there. And so it will create it will create this independently. It's that Docker zero bridge is the same as the one that was there in the single host. So if you don't specify anything, and if you run it, it will by default put it in the Docker zero bridge. So in case you see the same IP, that's what it is doing. So now let's create something that spans across the um, cluster. Before we do that, let's validate a couple other things. So on both of these, I'll run this command called Docker network ls. So one thing that got created after we did the swarm cluster is this overlay network. Okay, so so before this was not there, and this is where it facilitates the communication between the containers on different hosts, and that's the key to overlay networking. So let's go ahead and you can also define your own overlay networks. So let's create that green network over here. Now, if I try to create the overlay network on the worker node, it will not let me do it. So let's go ahead and try it. So I always type all of these commands on the master node, on the manager node. So let's go ahead and create this green network, and I'm specifying the subnet to be the 172.21. And there we now have the green network, and we could do .docker network ls here. And it will show that we now have the green command, and there is a green bridge, and there is a very useful inspect command. If you do the inspect, it will show you that what's the subnet, what's the default gateway, and all of the goodness. Okay, so let's create a service with 2 replicas on this green overlay network. And we will expose this with 8080 on the host and 80 on the container. So this is where the cluster networking and the ingress networking comes into play. So it's spinning up 2 replicas, and you will notice that if we do Docker PS here, you see that let's remove this. You see that there's this demo 1 VM we created. I'm sorry, container that we created, but you'll see that it spun out of the 2 replicas. It spun up one over here on host 2 and one over here. So now let's exec into those containers and see the networking inside, side by side. Docker exec -it, and this is the one on the green network, and we'll SSH in, and we'll do the same thing on this side. So let's run the ipadder command here to see what is going on. So we'll do ipadder, and you'll see that this container has 3 interfaces, 10.0.0.5. So let's break those down. So 10.0.0.5 is that ingress, that overlay network that we saw. Then we have the 10.18, 172.18, which is the Docker underscore gateway bridge. And then this is the custom green overlay network. Okay, so this is because we specified the ingress service, we exposed the service, we got presence on that network as well. So notice how there are 3 networks. This is the green overlay, and they're all unique. So let's compare them side by side. So this is the default ingress overlay network, and you can see 10.0.0.5, and here you have 10.0.0.6. Here you have 172.18.0.3, 3, and here you have 172.18.03. Now notice that that's the Docker bridge, so it can overlap. Okay, so this is the one that can overlap because it's only local, that bridge is only locally significant. And then you have this one as 3 and this one as 4. This is our custom green VNet 172.21. Let's take a quick look, and that's the green VM. So now let's go ahead and ping the green. Let's go ahead and ping. So we are on .03, so we'll ping 04. So if we ping 04, it should work. So there we can ping 04, and we should be able to ping the 10.10.06 as well. Great. So this is all working over, over this overlay network. So going back to the white drawing board, all of this traffic, when we ran the ping, it was going over the overlay network across the host. So now how do we validate that that is indeed happening? So let's do this. Let's run a continuous ping. So I'll clear this. I will make this a little bit bigger. And IP adder will just run this one more time. So we'll ping this container from host 1. .6. Notice we are on .5. So we'll ping .6. And while that continuous ping is running, we will run on the host itself, we'll run a TCP dump command. So if I have the TCP dump command over here, this is the overlay networking port. And when we run that, we should see the VXLAN encapsulated packet. All right, let's pause this here and look at this. So you could see that the outer packet is the host IPs 10.114 and 10.115 on port 4789, which is the VXLAN overlay port. And the inside ICMP is going between 10.0.0.5 and 10.0.0.6. So it is indeed going over the overlay. So now let's do that exact same test with the other IP for the green overlay. So we'll ping .4 here. And we'll run the same command here. Beautiful. And this is as good as it gets. You can see that we can talk between. The containers are on 2 different hosts. And this is the magic of overlays and VXLAN, where you can see the inside, the outer packet is 10.114, which is the host, ETH0 on the host, and the inner packet is the 170.21.03. And the last test we want to do is we will look at inbound and outbound from the container. So let's exec into the container one more time on both sides, and we'll do the final inbound and outbound. The test we did so far was what I would say was east-west. So this green flow right here, let me make it a little bit bigger. This was this green flow right here, this animated flow. And we're going to just validate that we can also do the north-south flow. So we will validate that we can do this egress from these containers that are on the green bridge, the green overlay network. So we'll just do curl if config.me, and there we can egress curl if config.me, and we can egress. And that's the exact same, and those are the IPs of the host itself. And if we run that same command from the host, we should get the same IP, and same thing here. And now to test ingress, we have to hit the host on that IP, on the host IP on port 8080. Remember, I'm allowing port 8080 to the VM. So let's build our curl command here. So these are the two IPs of the two VMs. So this is VM1. Oops. So this is VM1, and we'll do the curl with VM2 and 8080. And we do have to, so let me exit out. We have to come from outside. So I'm now exited out, and I will run this command from here. Maybe I could just do a simple grep on address. That way we can see that it will get. Now, the reason I have this container, this is the Nginx demo container with, it will just echo the address of the container it is connecting to. So notice that if we hit it again, it circles between 5 and 6. That's because of that ingress service that's load balancing between the two containers in the pod. So it will alternate between giving me 10.0.0.5 and 6. And same way we can hit the other VM, the other Docker host. And so we get 5, we run it again. It cycles between 5 and 6. There, this lays the foundation for ingress, load balancing, coming into the host, coming in from the host port. Let me show that particular concept where we are hitting the actual Docker host on port 8080, which gets forwarded to the container on 80. So these two things, this overlay networking and the service, lays the foundation for AKS networking. Let me just make sure I'm not missing anything here to show you. Yep, there, everything's covered for this session. I hope you enjoyed this session. Thank you again for joining me. Drop me a comment. Let me know if you have any question. This does lay the foundation for AKS series, networking series. So be sure to finish this before you start watching the AKS networking playlist. Thank you and have a great day.